The second derivative test. Okay. In a second derivative test, for extreme points, for extreme points, for extreme points, you must have dy dx equal to 0. Okay, always for extreme points. And now for second derivative, what you have to do is if um, for extreme points dy dx is equal to 0. Okay. So now if CFC be an extreme point, then the condition for the second derivative for maxima, local maxima, d2y dx2 is less than 0 at x equal to c. For local minima, d2y dx2 is greater than 0 at x is equal to c. Okay, now what does this mean? Let us take an example and illustrate this. Okay, let's take a very simple example to start with. Okay, the question here is, I'm not picking up from the textbook. Okay, okay, problem. The question is, find the points. Look at this very carefully. Okay, find the points of local maxima and local minima if any of the function fx is equal to x cube minus 6x square plus 9x plus 15. Find also the maximum and minimum values. You understood the problem?
Yes, sir.
Yes, sir.
So given here, what is the function? Fx is equal to x cube
Yes, sir.
minus
X
6
cube minus 6 plus 9x plus 15.
Now understand this problem very
9x
well.
plus 15.
Understand this
Yes, sir.
problem very well, very carefully, because these kind of problems you will find in section C also when you will be doing problems on economics. Okay. So this you will follow exactly the same
Okay, sir.
procedure. Okay. So these kind of problem will keep on coming. So first, when we are using second derivative test here, okay, we first find out f dash x.
Yes, sir.
Differentiate,
Sir,
find out
3x square
3x square minus 12x
minus 12x plus
plus
9.
9, which can also be written
Then
as
again f double dash
x
s.
square minus 4x plus 3. Okay. Now we shall
Yes,
find
sir.
f double dash x,
F double dash
second derivative.
x. Yes, sir.
Okay, so
Yes, sir.
second derivative is 6x minus 12. You get 6 times x minus 12. Okay. Now we have
Yes,
found
sir.
out the first derivative and we have found out the second derivative. Okay. Now what was the condition for extreme points for local maxima or minima?
F dash x is equal to 0.
Yes, for local maxima or minima, condition was f dash
Sir,
x is equal to
in double derivative,
hmm,
sir, in double derivative, we have to what we will take f dash x or f double dash x
f double dashed.
for local
Sec-
maxima.
No, for local maxima or minima, f dash x is equal to 0. Always. First derivative equal to 0.
Okay,
Always. For local maxima or minima, always first derivative is equal to 0. Understood?
okay, sir.
Now you factorize this. X minus 1. Okay. So what you ultimately get is, what are the values? Extreme values. What are the extreme values? X is equal to 3 or x is equal to 1. Okay. Now we shall check for maxima or minima at these points. Okay. How do you check for maxima and minima at these points? You consider the first point here. Okay. So at x is equal to 3. Check the sign of f double dash x. We only need to check the sign. Okay. We are not concerned with the values, whether it is positive or negative. At x is equal to 3. What is f double dashed 3? What is the expression here? 6 times x minus 12. So 6 times 3 minus 12, which is 6 into minus 9. Positive or negative? Is this positive or negative?
Negative.
Negative.
It's a negative.
We don't need to find the value. We simply need to see the sign. Okay. So therefore, what we say is, therefore, x is
Sir, at
equal to
x is equal to 3. Sir,
hmm,
Sir, at x is equal to 3, we will put the value of in f double dash x
At x is equal to 3?
or fx.
No,
Yes,
no.
sir.
We
F
we
double dash x.
f double dash x. This is the second. That is why it is called the second derivative test. This is the testing stage. Understood?
Okay, sir.
This is the testing stage. At the testing stage, you will put f double dashed. You will see. You will check the sign of f double dashed x. Okay. So first, you with the help
Okay,
of
sir.
f dashed x is equal to 0, you are getting the values of x. Okay. Now whatever values of x that you are getting in the testing stage, you will put it in f double dashed x. Okay.
Okay, sir.
So you
Okay,
have seen
clear.
that the sign of, see the condition also that I have given here. What is the condition? D, d2y dx2 less than 0, right? And d2y dx2 greater than
Yes,
0,
sir.
right? So that is why this is your testing
Yes.
stage. This is your testing stage.
Okay, sir. Okay.
Okay. So
Okay, sir.
you have checked the sign here. So therefore, what is actually according to this condition? What is my condition here? Which one? Which one should I take? Less than 0. This one, right? d2i dx2 is less than 0.
Yes, sir.
Second derivative is less than 0. So what is this point? This is a point of local maxima.
Maxima.
So therefore, we say x is equal to 3 is a point of local maxima. Understood? And what is the maximum value? Maximum value. Now this time, in order to find the maximum value, now you will put x is equal to 3 in the function, in the given function.
Okay, sir.
Understood?
Okay.
Okay, sir.
Yes, sir.
So maximum value will be f3, which is 3 cube minus 6 into 3 square plus 9 into 2 plus 15. Okay. So this value at x is equal to 3, the value is 15. Okay, you will get this value as 15. So we have checked for one point. Now we shall check for the next point. X is equal to 1. X is equal to 3 we checked. Now we check for x is equal to 1. At x is equal to 1. F now again second derivative, because this is again the testing stage. F double dashed 1 is equal to, and what is the function? What is f double dashed here? 6 into x minus 12. So 6 into 1 minus 12. So 6 into minus 11. Again positive or negative? Again negative. That means what is my conclusion? That therefore x is equal to 1 is a point of local what?
Maxima.
Maxima.
Sir, local.
And what is the maximum value? Maximum value f double dashed, sorry, f1. When you are finding the maximum, you are finding the maximum value then f1. And what is f1 here? 1 cube minus 6 into 1 square plus 9 into 1 plus 15. And that comes out to be 19. Clear?
Yes,
We'll
sir.
take another problem in order to illustrate this. Okay. The question is, we'll go to textbook problems after this. Okay. Find the points of local maxima and minima of the function fx is equal to x to the power of 4 minus 62x square plus 120x plus 9. Find also the local maximum and minimum values. Okay, let's see. Given here, what is fx? X to the power of 4 minus 62x square plus 120x plus 9. What is the first step? We find f dash x. F dash x here is 4x cube minus 124x plus 120. You can take 4 common. X cube minus 31x plus 30. Okay. Now find out the second derivative. F double dash x here is 12x square minus 124. You can take 4 common. You will get 3x square minus 21. Fine.
Yes, sir.
For local maximum minima, what do we do? Amir,
Yes, sir.
for local maxima or minima,
For lower maximum. So we will do
f dash x is equal to
double
0.
Sir,
0.
So what is the value of f dash x? 4 times x cube minus 31x plus 30 is equal to 0. That means x cube minus 31x plus
Plus 30 will be 0.
30 is equal to 0. Now this is
0.
a cubic equation. Okay, you can use factor theorem to solve this equation. Okay, the trial and error method. Remember class 10 trial and error method.
Yes, sir.
Class 10, you put x is equal to 1, x is equal to minus 1, and all that.
yes, sir, yes, sir.
Okay, you can use that method. Okay, otherwise you can uh, also solve this very easily if you can break 31 as minus x and minus 30x. Okay,
Okay, sir.
so in this case what will happen is you can take x common from here, you will be left with x square minus 1, and here you can take 30 common and you will be left with x minus 1 equal to 0. And now what you do is you break this x square minus 1 as x plus 1 into x minus 1. Okay, minus 30 times x minus 1 equal to 0. Next you can take x minus 1 common from here. After taking x minus 1 common, you are left with x into x plus 1 minus 30 equal to 0. That means x minus 1 into, if you multiply all this, you will get x square plus x minus 30 equal to 0. That means now you can again perform middle term factorization here. Okay, you can break this up as x square minus 5x plus 6x minus 30 equal to 0. Means x minus 1 x into x minus 5 plus 6 into x minus 5. You understood the factorization?
Yes, sir.
Yes, sir.
That means this is x minus 1, x minus 5, and x plus 6. That means how many values of x you are getting? You're getting 3 values of x. Okay, that means you're getting 3 points. That means you will have to check 3 times. Okay, so that means either x is equal to 1 or x equal to 5 or x equal to minus 6. Okay, uh, now we shall check at x is equal to 1. Okay, uh, f double dashed x, f double dashed 1, in fact, f double dashed 1 is how much? What is the expression for f double dashed x here? 4 times 3x square minus 31. 4 times 3 into 1 square minus 31. Okay, so this comes to this 3, this comes to 4 times 3 minus 31, which is greater than 0 or less than 0. We don't need to calculate. We just need to see whether it is positive or negative. Is this positive or
Sir,
negative?
negative.
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 That means, what can I say? This point of local maxima or minima? Tell me. Namir, you tell me.
Minima.
Sir, maxima.
Maxima.
Sir, maxima.
Why minima? Look at the condition here. d2y dx2 less than 0 for what? Local maxima, isn't it?
Yes, sir.
Remember this condition. X is equal to 1 is a point of local maxima.
Maxima.
And what is the maximum value? F1. Only when calculating the maximum value, we'll put it in the function. Okay. So F1 will come out to be 1 to the power of 4. Just put it in the function. Minus 62 into 1 square plus 120 into 1 plus 9 equal to 68. Clear? We checked for
Yes, sir.
first point. Let's now check for the other point. We have completed this point. Now we shall do this point at x is equal to 5. At x is equal to 5, f double dashed 5 is equal to 4, 3 into 5 square minus 31. So this will be 4, 25 into 3, 75 minus 31. Positive or negative? Positive.
Sir, positive.
Therefore, x is equal to 5 is the point of what? Is the point of
Sir, minima.
minima,
Minima.
local minima. Okay. And what is the minimum value? F5. Put it in the function. 5 to the power of 4 minus 62 into 5 square plus 120 into 5 plus 9, which will come to minus 316. Okay.
Okay.
Next, third point. What is the third point? Minus 6. At x is equal to minus 6. What is f double dash minus 6? 4 times 3 into minus 6 square minus 31. Okay. So this comes to 4 times 36 into 3 is how much? 108. 108 minus 31. Positive or negative? Positive.
Positive.
Therefore, x is equal to minus 6 is a point of, Amit, tell me point of what? Point of local
Minima.
minimum. Okay. And what is the minimum value? f minus 6. Put it in the function. Minus 6 to the power of 4 minus 62 into minus 6 square plus 120 into minus 6 plus 9, which is 1296 minus 2232 minus 720 plus 9, which will give you minus 1647. Clear? This
Yes,
method.
sir.
Yes, sir.
Now what I will define to you here is a point of inflection. Okay. We will take one example from point of inflection. I won't be able to complete this example, but I will start with it. Okay.
What is absolute maximum or minimum value?
Absolute maximum minimum value. Right.
It was there in the blueprints.
See, absolute maximum or minimum value means of you're getting
Yes,
various
sir.
points of maxima, right, in the function,
Yes, sir.
isn't it? You get the various points of maxima. Among those, there is one value that is the maximum of all the values. Among the local maxima, there is one value that is maximum of all the local maxima,
Yes, sir.
isn't it? See, if you get values like x is equal to 1, x is equal to minus 6, and x is equal to minus 5, at suppose these 3 points you are getting local
Yes, sir.
maxima. Okay,
Yes, sir.
then what will be the absolute absolute maximum? See, you find out f1, you find out f minus 6, and you find out f minus 5, right? You get three maximum values. Out of these three
Yes,
maximum
sir.
values, whichever will be the greatest, whichever will be the greatest will be your absolute maximum. Understood?
Which one will
Yes,
be?
sir.
Yes, sir.
Yeah, so that is what is meant by absolute maximum. Let us see this example here. And in the course of this example, I will define to you what point of inflection actually means. Okay. So problem, find the maximum and minimum values of the function fx is equal to x to the power of 5 minus 5x to the power of 4 plus 5x cube minus 1. Okay. That is a very straightforward, simple question. Let's see. First, we shall find out. We shall write the given function first, then we shall find out the first derivative. First derivative of this function is 5x to the power of 4 minus 20x cube plus 15x square. Okay. So now from here, you can take 5x square common and you can write this as x square minus 4x plus 3. Okay. Now you calculate f double dash x. F double dash x, we want to calculate, differentiate it from here itself. You will get 20x cube minus 60x square plus 30x. Clear? From
Yes,
this,
sir.
you can take
Yes.
you can take 10 out of these. Okay, and you can write this as 2x cube minus 6x square plus 3x. We can in fact take 10x square out. 10x in fact, not 10x square. You can take 10x out. 10x if you take out, we are left with 2x square minus 6x plus 3. Okay, so this. Now for what is the condition for local maximum or minima? For local maxima or minima, dy dx, oh sorry, f dash x is equal to 0. Put the value of f dash x. Okay, factorize the this expression that you have inside, middle term factorization, minus 3x minus x plus 3. What do you ultimately get? 5x square x into x minus 3 minus 1 into x minus 3. You get 5x square x minus 3 into x minus 1. So how many points are you getting? X is equal to 0, you're getting. X is equal to 3, you're getting. Right?
Yes, sir.
Okay. And x is equal to 1, you're getting. Okay. Now let us discuss at x is equal to 3 and x is equal to 1 first. X is equal to 0, I'll discuss later. At last. At x is equal to 3, what is the sign of f double dash x? F double dash 3 is equal to, what is the value of f double dash 3? You put it in the function. F double dash this, how much? 10 into 3 into 2 into 3 square minus 6 into 3 plus 3. Okay, so you get
Okay.
30 into 18 minus 18 plus 3. Positive or negative? Positive.
Positive.
Therefore, x is equal to 3 is the point of local what?
Minima.
Minima. And what is the minimum value?
3.
F3 is the minimum value, right? And what is F3 in this case? Put x is equal to 3 in the function. 3 to the power of 5 minus 5 into 3 to the power of 4 plus 5 into 3 cube minus 1. You get this as minus 28. Okay, this is
Okay, sir.
what your maximum value is. Now we check for the second point at x is equal to 1. F double dash 1 is equal to 10 into 1, 2 into 1 square minus 6 into 1 plus 3. Okay, so we get 10, 2 minus 6 plus 3. Positive or negative? Is negative.
Positive. Negative.
Therefore, x is equal to 1 is a point of local
Maximum.
maxima.
Maximum.
What is the maximum value?
1. F1.
f1, and the value of, put it in the function, the value of f1, you will get 1 to the power of 5 minus 5 into 1 to the power of 4 plus 5 into 1 cube minus 1. You will get maximum value equal to 0. Okay. Next, last we consider at x is equal to 0. What is f double dashed? 1. F double dash 0. You get 10 into 0, 2 into 0 square minus 6 into 0 plus 3. So this becomes 0. Now what happens? Now what to do? I did not tell you any condition for this, did I? Did I give you
No,
any
sir.
condition where d2y dx2 is equal to 0?
No, sir.
Then what will happen? How will you do this? Okay. So what I'll do is I'll stop here for today.